The Model Context Protocol has its biggest spec update since it launched, and the headline change is that they deleted the session ID entirely. If you build agents or MCP servers, this one is worth understanding carefully because the problem they solved is the exact same problem that trips up every stateful service you will ever run at scale. When MCP launched, it shipped with a session model that felt completely natural. Client connects, sends an initialize request. The server replies and hands back an MCP session ID. Every request after that echoes the ID. The server holds session state in memory. On your laptop with my one server and one client, it works perfectly. And then you deploy it. You put a load balancer in front of 3 replicas because that is how every production HTTP service on Earth is run, and it falls apart immediately. Here is exactly what happens. A client sends its first request with session ID ABC123. That lands on replica A. Replica A creates the session and holds it in memory. The client sends a second request, still carrying ABC123. The load balancer routes it to replica B. Replica B has never seen ABC123. It has no idea what to do. The tool call fails. This is not a theoretical edge case. This is what happens the first time you horizontally scale any MCP server in production. Teams hit this wall and reached for workarounds, and every one of them was bad. Sticky sessions pin each client to one replica, which sounds fine until that replica restarts and every session on it disappears. Redis solves the cross-replica problem but adds a network hop to every single tool call and introduces a new single point of failure. Deep packet inspection at the gateway, parsing JSON RPC bodies to figure out where to route is exactly the kind of thing gateways are supposed to save you from by early 2026. Enough teams had paid this tax in production that the maintainers decided to remove what was generating it. The July 28th release candidate makes a clean break. The initialize handshake is gone. The session ID is gone. Instead, every request carries everything the server needs inside a meta object. Protocol version, client identity, negotiated capabilities, all of it right there in the envelope. If a client needs to discover what a server can do, it calls a new discovery method that is completely stateless and cacheable. Nothing is held open, nothing is remembered between calls. Any replica can answer any request. You restart one, scale to 10, nothing in flight breaks. This is how HTTP has worked for 30 years. What about tools that genuinely need to pause and ask the user for something? Those used to require a long-lived streaming connection. Now they use a pattern called multi-round trip requests. The server answers a tool call with an opaque request state blob. The client gathers whatever inputs are needed from the user, then reissues the call with that blob echoed back verbatim. The server reconstructs everything it needs from the blob. It never held a connection open. It never stored anything. The state made a round trip through the client and came home. If this sounds familiar, it is the exact same trick assigned cookie plays. The stateless core is the headline, but this release also makes MCP behave like a normal operable HTTP API. Routing headers are now required on every request. MCP method, naming the JSON RPC method, and MCP name, naming the tool. Load balancers can now route on headers without cracking open JSON bodies, which is the most underrated change in the release. Caching metadata arrives with a time to live field so clients know how long to cache tool lists. WW3C trace parent header support means your OpenTelemetry collector sees agent traffic end to end with no glue code. And 6 separate CEPIs harden the OAuth story, with CEPI 2468 being the one to ship first. There's also a new extension framework that changes how the protocol grows. Instead of every new feature landing in the core wire spec, capabilities now ship as versioned extensions with their own release schedule to go official on day one. Tasks for long running work, where the server answers with a task handle the client pulls and cancels, and MCP apps, which lets a server ship an HTML interface the client renders in a sandboxed iframe. talking to it over the same JSON RPC already in use. A tool result is JSON, but sometimes the human on the other end needs a rendered panel, not a wall of text. Here's the design lesson that outlives this spec. When a system feels stateful, the instinct is to make every layer stateful to match. MCP did that, and it cost them load balancing, auto scaling, and clean restarts. The fix was not to make the protocol smarter, it was to make the protocol dumber and push state up into a layer that could carry it cheaply, and opaque handle the client holds and represents. The agent stays as stateful as it ever was. The wire got amnesia, and that amnesia is exactly what lets it run on 10 replicas behind a round robin balancer. Statefulness is a property of the application. It does not have to be a property of the wire. The spec finalizes on July 28th, so the window is short. Audit your MCP servers for anything held in process memory per session and externalize it. Confirm your client SDK sends the MCP method and MCP name headers, because gateways will start rejecting requests that omit them. Read SCP 2468 and ship it first. Deprecated features like routes, sampling, and logging keep working for at least 12 months, so migrate at your SDK space. The protocol got simpler, your agents get to scale. If you found this useful, subscribe for more deep dives on AI agents and developer tooling. See you in the next one.